In this problem, we have a police car traveling south towards Sioux Falls at 160 kilometers per hour, pursuing a truck which is traveling east away from Sioux Falls, Iowa at 140 kilometers per hour. Okay. At t equals 0, the police car is 40 kilometers north and the truck is 60 kilometers east of Sioux Falls. Calculate the rate at which the distance between the vehicles is increasing at t equals 10 minutes. All right, so in this problem, we actually have some variables. We have that distance is described by x, and this vertical distance here is described by y, so that's nice and simple. And we are interested in the rate at which the distance between the vehicles is increasing. That's this distance right here. I'm going to call it d for distance. Now we need an equation that relates x, y, and d. But luckily the Pythagorean theorem comes in handy here. So x squared plus y squared is equal to the distance between the cars squared. Now, in order to find the distance at which the rate at which the distance between the vehicles is changing, we want d dt, the rate at which d is changing with respect to time. We are given dx dt and dy dt. Dx dt is the rate at which this truck is moving. So we are given that dx dt is equal to positive 140 kilometers per hour. And we know that dx dt is positive because as this truck drives, x increases. This distance becomes greater. We also know dy dt, the rate at which y is changing. The police car is going at 160 kilometers per hour. However, as the police car gets closer and closer to Sioux Falls, y is decreasing. Therefore, dy dt is negative. Okay. Now we can go ahead and take the derivatives of both sides because we know dx dt and dy dt, and we want d dt. So even though there's three variables here, we know or want all three of their rates of changes. So I'm going to go ahead and take the derivative of both sides with respect to time to get 2x times dx dt plus 2y times dy dt equals 2d times dt dt. And we can divide both sides by 2 to get those out of our way. And now to solve for d dt, all we need to do is divide by t. However, we also need x, y, and d at the moment when t is 10 minutes. So let's do that down here. We're going to need x, y, and d, all three of those values at t equals 10 minutes. And since the speeds up here are in hours, let's go ahead and use hours. Let's use 1/6 of an hour instead here. Okay, let's redraw the diagram down here. Take a snapshot of this situation at t equals 10 minutes or 1/6 of an hour. So if this car is traveling at 160 kilometers per hour, then its distance right here is 1/6 of 160, because this is a picture of the 10 minutes here. So 160 kilometers per hour divided by, or times 1/6 of an hour leaves us with this many kilometers, which, let's see, that reduces to 80/3. And I'm going to leave that in fraction form so that I don't have any rounding errors here. So that's the distance y at 1/6 of an hour. Actually, that's not true because that's how far he's traveled in 1/6 of an hour. He's traveled, okay, he travels, let's write this out a little bit more here. The police car travels 160 kilometers per hour times 1/6 of an hour. So we just did this already, that's 80 thirds kilometers in the 10 minutes. But y is the distance remaining. So y is equal to his initial distance, which is 160, minus the distance that he has traveled, or 80 thirds. So let's see, let's get a common denominator there. So 160 times 3 is 480. And then I'm going to subtract 80 thirds, so we get 400 over 3 kilometers. There we go. Okay, and then let's see, this is a picture again of this thing at 10 minutes. Okay. Click a button here. There we go. Okay, now we need x at 10 minutes. So x is going to be 140 plus the distance that the truck travels. So the truck travels 140 kilometers per hour times 1/6 of an hour. So 140 divided by 6, that's 70 thirds kilometers in the 10 minutes. So therefore x is equal to the sum of his original, oh, I may have messed that up. I did mess that up. The original distance is not 160, that was the speed. The original position of the police car would have been 40 kilometers north. There we go. At t equals 0, the police car is 40 kilometers north. So this would be, let's see, 40 times 3, it's 120, minus 80, how about 20 thirds? That's a better number there. That's that 40 right there. The initial position of the truck is 60 miles east of Sioux Falls, so the truck starts at 60 kilometers, and then he travels an additional 70 thirds kilometers. So we want to do 60 times 3 is 180 plus 70 thirds, or 250 thirds kilometers. That's the value of x after 10 minutes. Now we can plug those values in up here, and we also are going to need d at 10 minutes as well. So let's go ahead and find this d right here. So again, using the Pythagorean theorem, we'll have 20 squared plus 250 over 3 squared is equal to the hypotenuse squared. So d is equal to the square root of 20 squared is 400 plus, let's see what that one comes to here. 250 squared is 62,500 over 9. And I think I'll go ahead and get a common denominator here. Not that it necessarily will simplify, but it will a tiny bit. So let's multiply 400 times 9 to get 3,600. So 3,600 plus 62,500 is 66,100 over 9. And of course the square root of 9 is 3. I highly doubt that we are going to be able to simplify that. We could probably simplify the radical quite a bit, but 60, so we have square root of 66,100 over 3. I'm going to at least see if I can take, I don't think this is going to work, but let's see, 66,100. If it's divisible by 9, it is not. So even if I try to simplify that radical, it's not going to reduce with this third here. So I'm just going to leave it like that. Okay, now I'm going to plug into this equation up here. Let's bring this down and plug in all of these values down here. So we have x times dx dt. That's right here. X is, we discovered that's an x value. I should label, that's a y value, and that's a d value. So x is 250 over 3 times dx dt is next. Dx dt up here is positive 140 plus y is 20 times dy dt is negative 160 all divided by d, so all divided by this radical 66 100 over 3 gives me the rate of change of the distance between the cars when t is 10 minutes. And now we simply need to approximate this answer here. Okay, so in my numerator I've got 250. Actually, I'm going to do this part first. Let's do 20 times 160 to get 3,200. So I'm going to do this minus 3,200. So 250 times 140 divided by 3 minus 3,200 is, I'm going to store this in my memory here, 8466.66666. So 8466.6 repeating, all divided by this other value. So now I'm going to take 66,100, take the square root and divide that by 3. Now that's, I need to put that in the denominator, so I'm going to do 1 over that, times our previous number there, gives me about 98.7945. And this should be in kilometers per hour. Okay, however, that is incorrect. So I'm checking my work here, and I've just noticed a simple error. 40 is equal to 120 thirds. 120 minus 80 is 40 thirds kilometers. That should be 40 thirds. For y, there, I don't know how I put 20, but it should be 40 thirds. Okay, so that's going to change these numbers a little bit. However, the process otherwise is correct. Let's change that number. So this is 40 thirds squared. Now let's go ahead and square it. So 40 squared is going to be 1600 over 3 squared is 9. Now let's add those numbers. So plus 62,500 is 64,100 over 3. Then that changes this number right there, and the number under that radical, which changes that. I think all of the other numbers are correct. So instead of 20, I should have had 40 thirds there, and then under that radical we have 64,100. Let's see what that comes to. So let's do the numerator first. So we've got, let's do this term first. So we have 40 thirds times 160 is negative 2133.33333. I'm going to store that number. then we'll do this plus or minus that number. So 250 right here times 140 over 3 is that number minus the number that I just stored a second ago. It's equal to that supposedly. Let's recheck that. 40 times 160 over 3 is 2133. Now I'm going to do 250 times 140 over 3 minus the recall, since it's still not the right recall number. Memory clear, let's try this. 40 times 160 over 3. Store that. Now 250 times 140 over 3 is that minus the recall. That looks more correct. Okay, is 9533. Point 3 repeating, that's in my numerator there. Now let's do the denominator. I'm gonna store that in my memory though. 9533.3 repeating. So let's do 64,100. Take the square root and divide that by 3. That all goes in my denominator there. Times 95. Nope, that didn't work. Okay, so we have 64,100. Take the square root over 3 is 84.39, whatever. That goes in the denominator. Times the numerator is 9533.3333333. So we get 112.963. Which is correct. Yay! So that is our final answer on this one.